Hello friends. So in today's question, a block of mass m1 20 kg is placed on a wedge of mass m2 30 kg, rest on a smooth floor as shown in figure. Friction exists between block and the wedge. Find the acceleration of each block if F is 180 Newton and second part F is 400 Newton. Solve the problem if force F 180 Newton is directly upward as shown in figure B. So these are figure A and B. So for A part we have to consider the figure A, and for B part we are going to consider figure B. And there is a friction between M1 and M2, and M2 is on the smooth surface. Same is this for this part also. So first of all, let us try to solve it for this figure A. You can say that for figure A, okay. So let's, for the assumption's sake, we assume that let M1 and M2 move together. Okay, you can say that let M1 and M2 move together with acceleration A. Okay. So you can say that the acceleration A will be equal to F upon M1 plus M2. From here you can say that the acceleration A is equal to F is 20 plus 30, that is 50. And let's draw the free body diagram of individual blocks M1 and M2 and try to use this relation, that is where acceleration is F upon 50. Okay. So we can say that, draw it for block M1. So we have this block M1, and in the downward direction we are going to have M1G, and let us suppose there is a friction, we denote it as Fr, and there is normal N1 in the upward direction, and the force with which it will be going to pull, let us call it as F. Basically it will be tension and T will be equal to F, so we are going to call it as a simple force F. And the normal N1 will be equal to M1G, and mass is given as 20, G is 10, so N1 we are going to get as 20 into 10, so we get N1 is equal to 200 Newton. And therefore we can write this equation as F, and it is moving with acceleration A in this direction. So we can say that F minus Fr is equal to M1A. M1 is 20, so we can say this is 20A. Let us call this as equation number 1. And for block M2, let's draw this is our M2, and we have a pulley here. A force F is being applied in this direction, and in the upward there will be also F, but in the vertical we are not more or less interested. We are interested in the horizontal part, and here is also pulley, and it will be also in this direction, and this will be F here, and because of friction here also will be friction, let us call that Fr, this direction. And the other forces which will be acting on it in the downward direction, we are going to have M2G, and there will be normal because of the surface, let us call that N2, and because of the M1 the normal will be N1. And it is moving with A acceleration in this direction. So we can write the equation as F minus F plus Fr minus F, this will be equal to M2A, and M2 is our 30, so this will be equal to 30A. F and F cancels out, so we get here F is equal to Fr rather is equal to 30A. Okay. And we already know the value of A, we substitute it here, and we get this as Fr is equal to 30 divided by 50 multiplied by F. 0 and 0 cancel out, so we get Fr is equal to 3 by 5 multiplied by F. Now let us find out what will be the maximum value of the friction. Okay. You can say that max value of friction, we call it as Fr max, which will equal to mu static to N1, and the coefficient of static is given as 0.6. So we can say that Fs max is equal to 0.6, and N1 is our 200. So we get Fs max is equal to 120 Newton. So this is a maximum value of the friction, or we can say this will be our limiting value of the friction. Okay. So we get Fr max is equal to 120 Newton. Okay. Now let us consider the part first. Applied force F is 180 Newton. You can say applied force F is given as 180 Newton. So for this force F, we try to find out what will be our Fr, because we already know the relationship. Okay, we can say that our Fr is equal to 3 by 5F. We substitute the value of F, we get 3 by 5 multiply 180 Newton, and which will be coming as equal to 108 Newton. So the value of the friction when force 180 Newton is applied is 108. And we compare this value of the friction for the maximum value of friction, you can say that our Fr is less than Fr max. So under this condition, there will be no slipping between M1 and M2. No slipping between M1 and M2, so which basically means they move with same acceleration. So means if acceleration of m1 is a1 and acceleration of m2 is a2, then we can say that a1 is equal to a2 is equal to a, which is f upon 50. We know value of force applied. Force applied is 180 Newton. 180 divided by 50. So we get acceleration of m1 is equal to acceleration of a2 is equal to 3.6 meter per second square. Okay, 0 cancel out 0, and this will be 0.6 meter per second square. In the second part, applied force F is now 400 Newton. Once again, we are going to find out value of the friction Fr. Fr is equal to 3 by 5 multiplied by F, that is 3 by 5 multiplied by 400, and this comes as equal to 80, and this means Fr is equal to 240 Newton. So once again, making the comparison, the friction as well the maximum value of the friction, so we can say that Fr is greater than Fr max. So under this condition, slipping between m1 and m2, so they move with different acceleration. They move with different acceleration. Okay, and as there is slipping, we can also say that the friction will be of kinetic nature. So friction will be kinetic. So let us find out Frk, which will be equal to mu k into n. Mu k is given as 0.4, sorry, this is n1 and this is 200. So we get kinetic friction Frk is equal to 80 Newton. Next, we are going to find out the value for the respective acceleration, that is a1 and a2. So we can say that our Frk is now 80 Newton, and let us say for block m1, so this is our block m1, force F and acceleration is a1, and we have here Frk. So we get equation as F minus Frk is equal to m1 into a1. So we get a1, F is 400, 400, Frk is, we get 80 Newton, and m1 is our 20, so we get a1. So this will be equal to, a1 is equal to our 16 meter per second square. And let us do it for m2. So we can say that for block m2, So this is our M2. There is a force F, and here also force F, and the friction will be acting F/K, and let us suppose it is moving with acceleration A2 in this direction. So we already know that in this case the formula is already there. So we can say that our F plus F/K minus F is equal to M2 A2. F and F cancels out, so we get A2 is equal to F/K divided by M2. So from A2, F/K is our 80 and M2 is our 30. So we get A2 as 8 by 3, and this will be coming as 2.6 meter per second square. Now we take for figure B. For figure B, in figure B, we can say there is not much of the change in the mass 1, but only change will be in the mass M2. M1 will be same, everything, only the changes will be present in the M2. So we can say that for M1 it is same. So let us draw it for M1. This is our M1. We have a force F and a friction Fr, normal N1, and downward direction M1G. Now in case of M2, this is our M2, and we have a pulley here. Now the force is in this direction. So this will be F, and here the force will be here F, and there is a friction, let us suppose that Fr. Okay. Fr, not 1. Because we are only interested in horizontal forces, so not much of the thing will be there. We can also elaborate on this. Will be M2G, there will be normal N2, and here will be normal N1. So if they are moving with same acceleration A, okay, moving with same acceleration A, then we can write the equation for M1. We get F minus F1 will be equal to M1A, and for M2 we can write the equation as Fr minus F, sorry, not 1, Fr minus F will be equal to M2A. Which basically gives us, from here we can say that if we solve this, we get that acceleration is equal to 0, and which also implies that F will be equal to Fr. So these are the, okay. First, if we solve this, we get acceleration 0, and if we put A 0, we get F is equal to Fr. Now the maximum value, we already calculated that Fr max is equal to 120 Newton. We already know this value. And so it is asked that the value of the force is 180 Newton. Okay, so we can say that for force F is equal to 180 Newton, and from the relationship we know that as Fr is equal to F, so from here we can say that Fr will be equal to 180 Newton, and the maximum value of friction Fr max is our 120. So we can say that Fr is greater than Fr max, therefore slipping between M1 and M2. So we can now find out what will be their different accelerations A1 and A2. Okay, so they are going to move with different accelerations. So we can say for M1, so this is our M1, we have applied force F which is 180, and now we have Fr kinetic and acceleration is A1. So we already know Fr kinetic is our 80, so we can say that F, that is F minus Frk, is equal to M1 A1. From here we can say our A1 is equal to 180 minus 80 divided by M1, that is 20. So we get A1 is equal to 5 meter per second square. And similarly for M2, so we already have the basic diagram. So this is our M2, we have a pulley here and it is in this direction F, and it will be F here also as well as here also, and we have a friction Frk whose value is 80, and it is moving A2 in this direction. We can say that Frk minus F will be equal to M2 A2, or we can say A2 Frk is of 80, applied force F is 180, and M2 is our 30. So we get A2 as minus 3.33 meter per second square. So this completes the question. The only important thing is that here the difference will be the direction in which the force is being taken with respect to block M2. For M1, there is not much of the difference between the value and the calculations. Okay, only it is dependent on 180. That is the only difference. Thank you.